Good morning or afternoon or middle of the night, whenever you're getting to this. We are in week 4, technically. One was spring break, one was finishing up chapter 8, so we're in week 2 of doing chapter 9, and we're going to be finishing off the year with chapter 9 and being done with it. So just in case you were curious about what's happening. So today we're doing our second method of solving quadratics, which is solving quadratics using square roots, which requires me to first of all introduce square roots just in case you haven't seen them before, and then show you how they're used in this. And then next time we're going to finish 9.3 by doing square roots from vertex form. This one's just standard form without a b value. So we're going to cover all of that today in our lesson, and I'm going to have my notebook ready for my notebook's ready for notes. Just want to, yeah, there we go. Okay, so here is 9.3 part A, which is solving quadratics using square roots. And if this still means anything, I'm on page 48. And I'm feeling kind of springy today, so I have a pink, a green, and a yellow highlighter. I don't know what I'm going to use, but those are the ones that I have, so they're free game. I don't know if you want to pause and check them out or whatever, but I'm a little grumpy that my lamp's not working the way I want it to. Is that better or worse? It's fine, whatever. You can see the shadow from my computer right here, and there's no light behind me, so it happens, it's whatever. Okay, let's talk about square roots. And let's first talk about what squareds are. So we hopefully already know that if I do a number squared, it's it times itself. So here's the reason for a square. A square is if I do like 3 times 3, I get 9. Or if I say 3 squared, that equals 9, right? The idea that it's called a square is actually from it being the area of a square. 3 by 3 units would have 9 units inside of it, 9 square units. So here's what a square root is. And when I was in high school, my little brother, who was, or still is, he's about 5 years younger than me, was like, what's that division sign thing with a V on it? I was like, I have no idea what you're talking about. And finally he saw my homework and he was like, that thing. So square root is this thing. It doesn't always have the little thing on the side. There we go. It doesn't always have this little thing on the end, but I like to do that so that way I know where the end of my equation is. One of my seniors always does this. She'll write the equation out and then finish the line and do the little part down. So square root means what squared would make 9. So what times what makes 9. And we know that 3 times 3 makes 9. And, surprise, surprise, the square root of 9 is also negative 3, because negative 3 times negative 3 also equals positive 9. Okay, so there's two answers here. There's both positive 3 and negative 3. So square roots are the opposites of squareds. Square roots undo squareds. Kind of like multiplication undoes division, and addition undoes subtraction, and all the rest. Square roots and squareds are opposites. So let's do some basic examples and then a little bit harder examples. Okay. So what if I wanted to solve x squared equals 100? Let's say. I'll do little examples on the side. Let's solve x squared equals 100. Well, what I'm going to do is I'm going to take a different color because I want to show you my steps, and I'm going to do the square root of both sides. So I already told you that square roots undo squares, so this is why this is useful. This whole square root thing cancels out this whole squared thing. Kind of like times 2 undoes divide by 2, add 2 undoes subtract 2, square root undoes squared. So what we get is that x equals 10, because 10 squared makes 100, or negative 10, because also negative 10 times negative 10 is 100. I think that's pretty neat. So, but let's say that I want to, oh, that's the end, that's the answer. Let's say I wanted to solve x squared equals negative 100. Well, then I do the exact same thing. I do the square root of both sides, and that cancels. But what times what would make a negative 100? Nothing. Because whenever I do what times what, two things multiplied together that are the same are always going to be positive, whether they're both positive or they're both negative. A positive times a positive is a positive, and a negative times a negative is a positive. So this has actually no solution. And it specifically has no solution because I can't take the square root of a negative. Let's write that down. Can't do square root of a negative. Okay. Now here's where I get people confused in class. They said, but last time it was positive and negative. Well, that's because a negative times a negative equals a positive, but it doesn't mean that. So it's always both positive and negative. It'll always be that way. So I can't do the square root of a negative, but it'll always be both positive and negative for the answer if it's a positive. Okay. This would be a graph that doesn't hit the x-axis. I'm going to switch back to last week's notes. So that would be one of these. There's no solution. The other one would be like this, where they're both at positive 10 and negative 10. I want you to be super aware, though. Look at how these are not the same thing. These are not the same equations. So let's talk about how to actually solve quadratics using this method, because this is a super useful method. So this method is used when I have standard form with no b. Remember, standard form is that one that looks like ax squared plus bx plus c. This is standard form if I don't have a b value. There's nothing there in the middle. It's just ax plus c. This method's also super useful for vertex form. So that's what we're going to do next week. Is we'll tackle vertex form next week, which is the exact same thing. It's just one extra step. We'll do that next week, though. So, for example, let's do a third problem. We're going to solve x squared minus 27 equals 0. So if we do x squared minus 27 equals 0, what I'm going to do is I'm going to add 27 to both sides, because this cancels out that. And I get the equation x squared equals 27. And then I'm going to do square root. Now this is a positive, so I can do the square root of it. Of course, and I didn't check this earlier, it's not a very nice number, and I wish it was. But we did nice numbers for the last problem, so it's okay. So what we get is that x equals the square root of 27 and the negative square root of 27. Another way we can write this, because, you know, we like to write things as concisely as possible. Mathematicians are lazy. Is that we do plus and minus square root 27. Okay. Now, if you have a calculator, sometimes your calculator will be super nice and sometimes it won't. So let me show you one example here. here's my calculator. If I do the square root of 27, it'll give me this as a decimal. I would much rather have it be the what's called radical form, which means it still has the square root, than for it to be a decimal. But on the graph, it's around 5.2. I was going to write the 1.9, but I just changed it. So on my graph, it would be at 5.2 and negative 5.2 would be my two intercepts. All your problems today are going to be positive and negative of a single same number. When we do this next week, it'll be two different numbers, kind of like when we did it with absolute value graphs, but it's all the same. Okay. If you happen to have a yellow calculator at home and you type in square root 27, I super wish I had one with me. What would happen is it would change it to be, I think it's 3 root 3. Yeah, 3 root 3. It'll change it to be 3 times the square root of 3, which is actually more useful than the square root of 27, but not necessary. It's okay. We're doing it from home, so I'm not going to teach you the super fancy methods with the super fancy calculators. Or if you wanted to get the 5.2 that I just got on the school calculators, the yellow ones, press that button right above enter, and it'll change it to a decimal for you, or vice versa. Cool. All right, let's do another one. Do you want to try this one on your own? Sure. You know what? I'm going to keep going at normal pace, but if you want to, you can pause this video, try to do it on your own, and then come back and see what happened. It's kind of like me waiting in class for you, but I don't actually have to wait in class for you. Let me just make it bigger. There you go. So we're solving x squared minus 10 equals negative 10. Pause it right here. Okay. So I'm going to add 10 to the other side. And you know what happens is that cancels out both sides, which is kind of scary, but that's okay. It just means that x squared equals 0. And 0 is positive technically, so I'm going to do the square root anyways. Cool. Well, if I do x squared equals 0, then what times what makes 0? That's 0 times 0. So I know that x equals 0. Is there such a thing as a negative 0? No, it's in the same spot still. So this is one that has one solution. This one looks like this, except it's centered on 0, 0. Whatever, it's fine, it's the same. So this has one solution, and this has two solutions. All right. Hopefully you got that one. We'll see. Okay, let's do another. Let's do x squared plus 16 equals 0. This might be on your homework because I'm making this problem up, but we'll see. Okay. Do you want to try this one? It's okay. You can pause the video. I have to switch to my face. That way you can actually see the whole screen because my desk is not as spread out, or it's not as much room as my work. Okay, so we subtract 16. Oh, pause it if you're doing this on your own. So I get x squared equals negative 16. Now, when I take the square root of this, what's going to happen? I'm going to get no solution. But here's the deal. What we write in Algebra 1 is that we write that there's no real solution. Because, and this is going to hurt you just a little bit, there is technically a solution. We just don't worry about it in Algebra 1. We come back and do it in Algebra 2. What the solution is it's called 4i and negative 4i, because square root of a negative kind of exists in electronics and stuff. And so what we do is we just sort of, we acknowledge that it exists, but we don't worry about it as much in Algebra 1. And that's okay. All right, let's do one more where it has an a value, because so far there's only been c's, no b's, and a's been 1. So let's do one last example, and then I'll set you free to your homework. So let's do negative 5x squared plus 11 equals 16. Same thing as before. I'm going to subtract the 11 to cancel that out. And I get that negative 5x squared equals 5. And now, when I square root, oh, I can't square root yet because there's that negative 5 in front. So what I have to do is I actually have to divide both sides by the negative 5, because that will cancel that out. So what I get is I get x squared equals negative 1. Oh, I can't do the square root of negative 1. It's the same thing as last time, which means I didn't need to make up that example, but it's okay. So once again, we say this has no real solution. Don't say there's no solution, because there technically is one or two, but we'll just say that there's no real solution and call it good. Okay? Last time I gave you some extra examples, but I think this will get you far enough into your homework that you don't need me for anything else. So, without further ado, here's your homework for tonight. It's 6 questions, or for the week, because you know. So I would recommend doing these with your notes open, and if you need any help, please come to my office hours, because I am here for you. I want to support you. This is from Big Ideas 9.3. This is part A. So next time I see you, which is on Monday of next week, we're going to use this for vertex form, which has parentheses in it, so it'll just be one more step at the very end, which is fine. You can do it. I believe in you. Hey, stay safe, and have a good week. Okay, bye!